Assalamualaikum and good morning. This is a video for conceptual design for our project cargo cycle. Okay, firstly we go to the morphological chart for this cargo cycle. For the first subfunction is the cargo type. We have three solutions for the cargo type. The solution 1 is wood material. Solution 2 is full metal material. The solution 3 is the metal, but just like basket, not full. The second sub function is steering. For solution 1, we use the back steering control. Solution 2, we use the front roller control. For solution 3, we use all wheel control. The solution 4 is we use the follow control. For the third subfunction is transmission. For solution 1, we use the belting gear transmission. The solution 2, we use the chain gear transmission. For solution 3, we use the road gear transmission. For solution 4, we use the gear to gear transmission.
For the second part of morphological chart of the cargo cycle, you can see the subfunction transmission speed had two options. For the first one is multiple speed. He had 1 to 6 speed. And for the second one is a single speed. And then for the cargo position, we had three options. For the first one is at the front. You can see the cargo at the front and the bicycle at the back. And the second one is on the back. The bicycle on the front and the cargo on the back. And for the third one is side. The cargo, we put it on side and the bicycle put side to side to the cargo. And for the last sub-function, wheel tire for the cargo. For the first one, we had two big tire, you can see, and a small tire. You can see this one is the small tire. And the second one we had two big tire. You can see two big tire. You see two big tire. And then for the last one, we had four small tire. You can see this one, and one. And the feature. For the last one, for the feature, for the first option can be 4, and then for the second it can be separate. What means it can be separate? It can be separate between the bike and the cargo. And the third one is static, and it stuck with the cargo and the bike.
Okay, next we go to the concept design. This is a concept design number 1. For concept design number 1, subfunction choose. For cargo type, we use the metal basket. For steering, we use the follow control. For transmission, we use a belting gear. For transmission speed is a single speed. The cargo position is at the side. The wheel tire type for cargo is too big at the middle. And the features of the concept design number 1 is the cargo static position cannot be full and cannot be separate from the cycle. Okay, for the concept design number 2, subfunction we choose is for cargo type, we use the metal basket. For steering is front control. For transmission, we use a chain gear. For transmission speed is a single speed. The cargo position at the front of the cycle. The wheel tire type for the cargo is 4 small tire. And the features for the concept design number 2 is the cargo can be separate from the cycle. We use the clamp for the connection between the cycle and the cargo.
For the third concept of our design, you can see at the morphological chart, we selected for the cargo type, we selected option number 1, wood. For the steering, we selected follow. Option number 4, transmission, we take option number 2, the chain gear. And next, for transmission speed, multiple speed. For the cargo position, we selected at the back. And for the type of cargo, we selected at 2 big tire. And the feature, it can be separated between the cargo and the bicycle. And for the last concept for our design is concept number 4. We can look at the topological chart. For the cargo type, we selected at option number 1. And for the steering, we take option number 4, the follow. And for the transmission, we selected at option number 2, the chain gear. For the speed transmission, we take a single speed. And for the cargo position, you can look on the picture at the back. We selected at the back. And for the type of cargo, as you can see, we put a small four small gear. And for the last one, for the feature, it's static. Yeah, as we can say, it can't be separate between the cargo and the bicycle. So next, we carry on for the concept selection. For the first one is absolute criteria. As you can see, the filter number 1 is for the judgment of functional flexibility of the design. And for the second filter, based on assessment of technology readiness. And for the third one, engineering characteristic. You can see for the concept number 1, we to get non-function. For the filter 2, condition. For filter number 3 is good. For the concept number 2, filter number 1 is condition, filter number 2 condition, and filter number 3 is go. And for the concept number 3, we put that filter number 1 is condition, filter number 2 condition, filter number 3 go. And concept number 4 is non-flexible. And filter number 2 yes, filter number 3 is go.
Okay, we are now go to the concept selection. B, relative criteria. We use the slot box for the datum of the relative criteria. For the criteria 1, the concept design number 1 for low cost is better than, low maintenance is lower than, for durability, weight size and reliability is same as the term. For safety, heavy duty and storage is better than. Easy to use, same as. The sum of better than for criteria 1 is 4. The sum of lower than for criteria 1 is 2. The next score is 2. Okay, for criteria 2, the better one is the low cost, durability, weight load, heavy duty, reliability, and the storage is better than the datum. For weight and the size is lower than datum, and low maintenance, the safety and the easy to use is same as datum. For sum of better than datum, for criteria 2 is 6. For sum of lower than datum is 2. The net score for criteria 2 is 4. Next is criteria 3. For the better than is low cost, weight load, heavy duty, and the storage is better than datum. For low maintenance, durability, the safety is lower than datum. For the size, reliability, and easy to use is same as datum. For the sum of better than for criteria 3 is 5, and the sum of lower than datum is 3. The net score is 2. For criteria 4, the better than datum is the low cost, the weight load, and the storage. For lower than datum is low maintenance, durability, safety, the size. The same as datum is heavy duty, reliability, and easy to use. The sum of better than datum of criteria 4 is 4, and the sum of lower than datum for criteria 4 is 4. The next score is 0. From the result, we can find that the rank of the criteria is number 1 is criteria 2, number 2 is criteria 3, number 3 is criteria 1, and the last is criteria 4. From the result, the criteria 4 is need to avoid, and the criteria 1 to 3 can go to the other for the selection of the final project.
So, for the last concept selection is scoring method. The scoring method that we use is WDM. WDM is a weight dimension metric. For the dimension metric, you can see the criteria is material cost, manufacturing cost, repairability, durability, reliability, time to produce. So the highest concept of the scoring method is the concept number 2. As you can see, it get the highest score from the others. The total score is 7.26. It make it number 1 scoring in the scoring method of our design. You can see the material cost, you are rating 8, manufacturing cost 7, repairability 7, durability 8, and reliability 8, and time to produce is 7. So that's all for us. Thank you for hearing.